And I'm also very happy to introduce the last speaker. We invited expert Egbert Lox, Senior Vice President of the Government Affairs of Umicore. And also there I have this nice personal anecdote. When I was young, studying engineering, I did, as many students, go and work a month in a company. And I just said, where you can earn the most money. It was working at night in a company called Union Minière in Hoboken. And I must confess at that time, but it's already 30 years ago, as a student of chemical engineering, I was quite surprised what was done with the waste. But of course, this has totally changed. We have now Umicore, a really top company on recycling. So I'm very pleased to have you here with us. Thank you.
Yes, thank you very much for the nice introduction. Actually, when you were explaining that I triggered some memories with you for your student time, I was afraid that you would refer to my time as president of the student organization. That you have seen, or you remember something that I don't remember any longer. But it was less. So indeed, thank you for telling that our company really made a very big leap forward and left behind history that is history, and that we do much better today, and we even strive to go beyond that. I brought with you a presentation that I was invited to give just a week ago about at a lunch and learn event of our post, which was extremely interesting. And you will see I included some references, some examples on that, on an action that a post could do in what I'm going to say. So urban mining, finding opportunities in consumer gadgets. You will discover that I'm very well aligned with the previous speaker, although we didn't do any proactive alignment. But I can complementary fill in some examples what an industry thinks about that. All right, and now that is of course the first question. Thank you. So you have seen an example on the growing importance of metals in electronics. I'll give you a complementary example for the growing importance of metals in renewable energies in toys. This graph shows the tools we are using since industrialization, let's say the 17th, 18th century. Windmills were the big tools that we used to harvest energy. At that time you needed windmills of wood, carbon, and some iron and some lead. That's it. Then you make a windmill that's grinded our grain and did the thing. If this is in your side, I can put it a bit down. Okay. And today we are back at windmills, much bigger windmills, much more complicated machines with all kinds of steering, electronics, and the likes, corrosion resistance. And you see, we almost need half or more of the periodic system to make those devices harvesting us in a renewable way the energy of tomorrow, the electricity. And in between that, you see cars increasingly becoming computers on wheels and other devices. So through that is a message we need increasingly more of those so-called technology metals. So that are metals that you need to make high-tech and have a function. The result is that an increasing amount of those metals are on the road, on the earth, on the surface, and divided in electronic and electric equipment, which already has in it more than 40% of the world mine production of cobalt, tin, indium, ruthenium, rare earth elements, and the likes. And for example, 4% of gold and silver, 20% of the cobalt, are in mobile phones and laptops. So that is an enormous application for those technology metals. Cars, more than 60% of the PGM stands for platinum group metals, so platinum, palladium, rhodium. More than 60% of the annual production of those metals goes in cars, in the exhaust system, for a very good reason, to make clean air and to contribute to human success. And increasingly more different metals come because the electronics in cars, the electric engines, small engines for all the actuators and so on, all of that means an enormous increase in need for technology metals. And clean energy already showed you for the windmills, the solar panels, and you need a lot of these metals. So that can only be meaningful on the long term if those metals are used, reused, used, and reused again. If this circle can be closed. And Umicore does that already for many of those high-tech metals. And so we apply our knowledge in chemistry, material science, and metallurgy to make material solution. This means material that solves a function, solves a problem, like making a carbon monoxide be transformed into carbon dioxide, so making clean air, in capturing a photon from the light and putting it into an electron, and so on and so on. So we are already very active into that for several sectors. But what is unique at us is that we have developed along the lines of making those technology solutions. We have developed the know-how and even pilot plants were needed to recycle that. And I'll show you the examples. We have been doing that in a very proactive approach. This means we have been taking investments before the economic viability and mass market is already there. But really to show that this is not just a nice slide, but is a reality at our company. Now, our products and services cover 29 metals. You have already seen the periodic system. And in the previous speaker, now you see the pilot periodic system that is covered by Umicore. And that is quite some elements from Cobalt down to neodymium. If you look those metals in where you can find them in the European Union table of critical materials. So critical materials means on the y-axis you have an index describing the criticality of supply. That is a rather complex index, taking care of many factors. And on the x-axis you have the economic importance for Europe. This type of slides exists for China, for the United States, and the likes, and is slightly different. But nevertheless, for Europe, and the critical elements are all put in, they are the ones that are in the upper right quadrant. And I've circled with red, full lines and dotted lines, the elements that are Umicore products. And you see we are with our 2 feet within the critical materials list. And we see that not as a threat, but as a challenge and as an opportunity to do a good job and to make sure that we can decrease this criticality by mounting the recycling. So that is very short our story. Now, I brought with you some case studies, so to really describe live how we do that and what we have been doing. And the first case study is actually very old. It's 200 plus years old. We did circular economy already before probably the name was invented. And this is for what we call the dealing with products that have a high concentration of precious metals. And high concentration of precious metals is, for example, in unused jewels that people inherit from grandmother and don't like the design. It is an unused or not any longer used forks and knives and silver cutlery that you inherit and don't want the design. Or recently more unused or not any longer used wedding rings. And all those things you can bring to Umicore. We have a dedicated factory in Pforzheim in Germany where people come with their not any longer used precious metal containing stuff. We analyze that, we give you some money, and it goes in our recycling. This is the basis of a big industrial operation that started 300 years ago, not with wedding rings, but with coins. When there was all these small kingdoms that became bigger countries and then formed the Federal Republic of Germany, every time a currency reform was needed and every time those gold, silver containing coins had to be remade. And we positioned ourselves as the right company to be there. So we do that already since 200 plus years. And it shows that the circular economy model can really operate, of course, while knowing that this is triggered by the fact that those elements that we recycle have a very high value. But more recently, we have been adding examples where it is less obvious. And less obvious is case study number 2, our recycling unit for products with a lower concentration of precious metals. You see here the picture of our Hoboken, Antwerp facility, where we process, amongst others, and not only, but amongst others, electronic waste, used computers and used mobile phones, a site of industrial diluted waste. And we are like the top technology company to have the ability to extract the highest amount of those metals at the least energy cost and energy use, and also the least pollution. And that is a big change from the history of our company. So we have invested heavily in all those surrounding aspects to mount that. And so the message is, the logo is, this is waste that is a bit less visible. This is electronic waste. And the output of this company is gold bars, silver bars, and this type of thing. And we have proven that through technology and really continuous investment in technology and research, you can do that in a sustainable way and also in a profitable way. Now, to be able to do that, we have to understand more than while processing primary metals, that this is needing a full chain, a chain that starts with consumer products that at the end of their life are collected, are dismantled, shredded, sorting in a intelligent way. So the word shredding invites you to think this is a brutal, no brains operation, but you need a brains operation to do it well. Otherwise, you make it even worse. And then end processing. Now, if you look at the numbers, the use, of course, this is millions, hundreds of millions of users. This is the people, the consumers that have the money, the wealth to have those devices in their hands, in the use. The collection is done in the world about by 100,000 companies, ranging from very good to extremely bad. The dismantling, shredding, sorting, so where really technology is needed, only about 1,000 companies in the world master that. And for the final step, the quality refining of this waste and quality extraction of the valuable metals out of that, only about 10 companies can do that worldwide. At this point, I want to make a small hook to the previous lecture. If this is to be done on a let's say regional or continental rather than a global context, so to make that so successful, we buy waste all over the world. And this is because we have the technology, the insight, how to make the mixture to get the best thermodynamics working. So we mixture some electronic waste out of, let's say, Belgium, with industrial waste out of a smelter in Bolivia. And only we know that on such a good scale, what you have to mix with what, so that the highest amount of those metals come out. So, of course, this has to be balanced, and I fully agree. Shipping around waste just in the world needs to be very well balanced as to CO2 consumption and so on. But this is, however, the reality check I must give. Just on a smaller scale, so a continental scale, you risk to have a lesser efficiency in the last step. So you really have to strive for top efficiency, and that means we have to look at the world. The force, the strength is in the enormous quantity. That differentiates us from people that try to do it on a small scale. So, okay, this is a bit of technology. But then collection, and that is why I added those points, and I'll just go quickly. I will share the slides, of course, with you later. But collection, increasingly we see that postal services, which are basically the services that come to your door, and increasingly have lesser letters to carry because you send them electronically. But those postal services, those infrastructure, those logistics can be used for other things. For example, the United States has mounted recently, and of course, you know, the United States is a very big country, but they have mounted indeed the service given to the US Postal Service to recycle used electronics. And there is all kinds of models. I'm not going into detail, but it deserves your attention. It deserves your attention because it is really very pragmatic. It is using existing infrastructure, people and trucks when they are empty to take back the packages up to 20 kilograms. And then sometimes the cost of that is paid by the waste buyer. Sometimes the cost of that is borne by the US Postal Service, and sometimes by the makers of the new equipment. So there's several models, and that is basically the 3 slides I have. And sometimes the service is focused only for people that work for governmental agencies, because they want to lead by example, and they have a controlled area. But ultimately, it's the target to roll that out to the whole United States and to every inhabitant of that. So all the websites that describe that in a lot of detail are included, and I'll share that then with you. Okay. An example that I also want to share with you. Some of you might have seen that recently means 2 weeks ago, there was a 10th year anniversary event of this Worldloop in Ter Hulp with Desmond Tutu and Toos Tielemans present. And this is like an organization to which Umicore, along with many other companies, is contributing, in which we say it's not meaningful for mankind on a global scale to just start recycling the computers that we don't need any longer because they are maybe too slow, or also the latest software doesn't run on them. But we have this service that you can give those computers, they are checked and then sent to Africa as working computers with a lot of education locally, both to repair those computers and to utilize them, and also a lot of technology given to the people to, at the end of this second life of these tools, to then dismantle them in a meaningful way and to send back, for example, the motherboards with the precious metals in, to send them back to Umicore in Hoboken. So we make a world loop, but helping also the other countries, and also that was addressed in your comment, to have trades that instead of aid. So that fully falls in your example. This is just one. There are many organizations who do that, but this is one organization that Umicore has spearheaded along with other companies, and that we are proud to be supporting since at least 10 years. I have also there 3 slides, but I skipped them. You can find all of that on the Worldloop internet site. But you see, there is an organization, there are companies that have capabilities, and especially special attention to the local entrepreneurs. We invest in having locally infrastructure and trained people, a trained workforce available to do all those jobs as well as we would do them here in the Western world. Okay, case study 3, a little bit faster. I have been talking all the time about precious metals. I say, yeah, of course, it works well, the circular economy, because they are expensive. That is true. However, it's not limited. Our activities are not limited to those metals. I'll show you here an aerial view of another big Umicore plant in Flanders, but not in Hoboken, 30 kilometers more to the east. A little bit better hidden is our big production unit in Olen, Umicore Olen. That works with cobalt, nickel, germanium, making them, and now also building up the recycling of that. So germanium is a metal that you use in substrate optics. Many of you will not see immediately germanium, but it is, for example, the basis of LEDs. And LEDs, light emitting diodes, is the new way of lighting. So all of that builds on that. You use it also in high efficiency solar cells, the so-called concentrated photovoltaics, which is less evident to be used in Belgium, But for example, as of Spain and further down south, that would be, and actually is also used as the technology of choice. This technology is also applied on spacecraft satellites. You see here the one of the Mars rovers, Spirit and Opportunity. And I assume you don't know, but those solar cells, the base of that has been made by Umicore and Olin. And of course, this is for us an example of a dissipative use of this method because we can't recycle this one. We can't disassemble and get it back. So this is gone. But there's fortunately enough to be re-added through the zinc refining, germanium being a bimetal of zinc. So also for this metal, we have mounted the technology and the infrastructure to recycle them with the new pilot plant operates since 1.5 years only in Poland. And I'm coming to almost the end. I have a fourth case study, again, being materialized in our big plant in Olen, where we make and recycle products on the basis of cobalt. So cobalt is a metal that finds its way in many applications, like paint. It's a hardener or a catalyst in paint. It's in hard metals, the drills, saws. It is used in tires of cars, and so millions of applications. There are also concentrated end-user market in turbine blades for airplanes, but also for power generation. And that, together with rhenium, is the basis of the so-called super alloys that allow you to operate those turbines at higher and higher temperature to make them more efficient. We recently, like 3 months ago, bought a company to make also this recycling feasible. And so those products we make, and I forgot to say actually the biggest application out of Umicore side is the use of cobalt in the lithium-ion batteries. We are the biggest producer worldwide of lithium cobaltite, lithium cobalt containing cathode materials that are used in your mobile phone, electrical car, eventually mass storage of electricity. And that is actually the example for those metals. We also have already mounted the recycling, although the economics is much less evident. It much higher depend upon the price fluctuation of cobalt. Nevertheless, we did that. And sometimes even we saw that, for example, the application of cobalt in the batteries of electrical vehicles, which are big devices. You see here a big device. For those devices, there was no dismantling yet, no sustainable, good and high technology dismantling yet available. And thus we have mounted on our own expenses dismantling centers, pilot centers, and collection points in the United States, in Germany, in Belgium, and it's all nicely disassembled. And we study the disassembling, we videotape the disassembling, we give feedback to the car company which part of the disassembling runs smooth and fast, so which is like reversing the robot, but also which parts do not run smooth. For example, smooth is if you have to screw out a screw because it has been screwed in. That's okay. Robot can be just reprogrammed in the reverse mode. But if something is glued, that's evident. So all that feedback, so we take that, we analyze that, and we give that feedback to the car makers in this spirit of design for recycling. It's a small application, but nevertheless, everything starts with a small step. And we send then back those fractions to the companies that can really do that in a good way. And of course, the cobalt-containing fraction comes to Umicore. All right. With that 4 case studies, I can conclude with, however, some warning messages. Warning in the sense that don't think it is very straightforward and obvious, because recycling is dynamic. This is the first warning message. Products are changing rapidly. That applies especially to electronics. While we used to store our data on a CD, later on a DVD, later on a USB stick, in the meantime in the cloud. But that for material use is, of course, completely different. So that is happening in time frames of years. And of course, to mount your recycling and dismantling on that, and then the whole thing is virtual, so to say, it's not obvious, so we have to take that. But increasingly, we have the so-called convergence of devices. Your phone and your tablet become a smartphone, and the smartphone has a lot of functions with less use of metals. It's all very meaningful, but this means that the unit weight decrease, and so that per phone you have less metals to recycle. Again, on one hand, very positive, but on the other hand, your plants have to be able to deal with that. And so those trends we already see for electronic waste, we see already today. This goes so fast, you see it today. To not just sit there and say, okay, that's a pity and a problem. We have been investing heavily in research, and not only technology research, but also like logistic research and more societal type of research. And I want to draw your attention to two projects. One is the very big 2020 project that we have, as you see, been mounting with many partners, and that has been submitted to the Horizon 2020 for funding, and we expect it will get through. This will give a basis for continuous improvement and study of all those various steps of this recycling chain. And then the last thing is very actual. I'm just two days back from Budapest. We also mounted with this data are not done because we were not allowed to talk about it before submission, before defense. But we submitted with 120 partners, which is 40 companies, 40 universities, and 40 technology organizations like Vito Style. We submitted a proposal for a raw materials knowledge innovation community, which is one of the bodies, one of the tools that the European Institute of Innovation and Technology uses to promote jobs and business, starting with startup companies in Europe. And I'm so on the three axes of helping research technology, where already all the channels exist, helping industry and SME, especially for SME and startup, that is more new and not so obvious in the existing channels. And most of the channels forget, if I may say so, or have not explicitly taken care of the link to education or higher education on the same topic. So those three pillars are before and back. That's why I say 120 partners, 40, 40, 40. And we won the race. So I'm very happy. So we were in Budapest, and 2 days ago we got the green light. This is a 7 years project with a total volume of €2 billion, of which €500 million is funded by the European Union, and the rest by industry and users of service fees. So we won the race, and that translates into big action starting with collocation centra, one of the collocation centra that's where industry and local industry, local universities, local RTOs fight each other. One of those collocation centers will be here close by. Okay, and so with that we joined the three existing kicks. There was a climate kick, a Inno Energy kick, and an ICT lab kick. Those three already exist and have already proven their generation of startup companies and new businesses. All right, and I think my time is too short, but I want to end by inviting you, please have a look at the website of the DG Environment European Commission, where they have a very nice documentary on circular economy, including a small movie where you can see some of the Umicore operations live. And just showing that circular economy is something also for industry, against some other people's opinion. I'm referring to Business Europe letter that thinks that industry is only hampered by circular economy. No, it's our basis. So I invite you to support this basis. Thank you very much for your attention.